In this lesson, we are going to learn how to determine the point-slope equation. So let's write that down. We have been looking at this in the previous lessons already, but that's the one that looks like this, where we've said that this over here is the slope, and then this here part and this part here is a random point that we will use. But we're going to do it based upon a parallel line. So we've already looked at parallel lines in the previous sections where we've looked at the slope-intercept form, standard form of a line. And so we should remember by now that when two lines are parallel, they have the same slope. So we can say that the slope of the line 1 is the same as the slope of line 2. So they say, determine the point-slope equation of a line which is parallel to this line. Okay, so let's go write out point-slope form. We know that that goes like this. And we know that if we look at this line over here, we know that that is written in slope-intercept form, where you can say plus c, or some teachers use plus b. And we know that the number in front of the x is the slope. So that would be this number over here, which is actually a -1. So then the slope of this line is -1, but then that means the slope of this line is also -1 because the two slopes are equal to each other because the lines are parallel. So then we can say that this slope is also going to be -1. Now what we need to do is take this point and plug it in. So this is an x value, so that would go over here. Remember, we don't use this x over here. And then this here is a y value, so that would go over here. And so we end up with y take away 2 equals to -1, and then x take away -4, like that. And so we end up with y take away 2 equals to -1, and then this can become a plus, so it's x plus 4. And that is the answer in the point-slope form. So here's another example. So they want us to determine the point-slope equation. So let's write out the point-slope equation formula, which goes like this. Of the line which is parallel to this line. So once again, when two lines are parallel, then remember, parallel looks like this. Whoops, not really like that. It's more like a railway, like a train railway, like that. So we know that their slopes are equal to each other, like that. So we need to go get the slope of this line. Now some of you watching this are going to be like, oh, Kevin, easy bro. The slope is -6 because we know that the slope is always the one in front of the x. But you would actually be incorrect. The reason is that you first have to rearrange this equation to be written in slope-intercept form. Okay, so at the moment it's not in slope-intercept form. To get it in slope-intercept form, we need to get the y by itself. So what I'm going to do is I'm going to take the 6x and the the 6x to the right, so it becomes positive, and the 12 to the right, so it becomes negative. Then I'm going to divide everything by 3 to get the y completely by itself, so you end up with a 2x take away 4. Now that it is written like this, we can say that the 2 is the slope. So we can say that the slope is 2, so that means the slope of this line is also going to be a 2. So let's quickly go fill that in. There we go. Then we need to take this point. So this point over here is the x value, so that would go there. And then we put the y value. This y value, we're going to put it over there. Okay. So we end up with y take away -4. Don't worry about the two negatives. We will sort that out just now. And then x take away 3. Now, two negatives, of course, we're going to change that to a positive. And so we end up with that over there.